Okay, we're on Chapter 11, Section 3. So we're going to do problems 7 through 12. So it's this group, kind of like the one we had earlier. So we have 100 college seniors attending a career fair at a university. We're categorized according to gender and according to primary career motivation is summarized here. So we have male and female, motivations, money, allowed to be creative, sense of giving to society. And if you add all this up, there are 48 males, 52 females, that adds up to 100, 31 interested in money, 38 interested in being creative, 31 society, you add those up to get 100. So it says if one of these students is to be selected at random, find the probability that the student selected will satisfy each of the conditions. So 7 is female. So we just look at the number of, remember, probability of an event occurring is the number of instances of the event divided by the total number of instances in the sample space. So our sample space is 100. At least we are, if we start with just selecting one. So the denominator is 100, and the number of people that are females is 52. So we get 52 out of 100, which can be simplified. You can divide both these by 4, and you'll get 13 over 25. So that's the probability of picking a female at random from the 100 people that went to the career fair. Okay, so the next one is motivated primarily by creativity. So again, this is just a single event, not multiple events. So again, it's the number of people that are motivated by creativity divided by the total number of people. So again, the denominator is 100. And we look at our table and we see that there are 38 people. So we get 38 out of 100. And that can be reduced down to, we can divide both by 2. You get 19, which is a prime number. 1950, it's the probability of randomly selecting someone whose primary motivation is creativity. The next one is the probability of not being motivated by money. So the probability of not being motivated by money is going to be equal to 1 minus the probability of being motivated. So there's actually 2 ways you could solve this. You could do the first one, which would be what are the other things to be motivated by? Creativity, society. You could add those 2 together, which would be the numerator, and divide by 100. So let's do it both ways just to show you. So doing the left-hand side, you would take the people who are motivated by creativity, the people motivated by giving to society, that would be the ones not motivated primarily by money, divided by the total number. So that would be 79 over 100. Is that right? 69 over 100. So that would be this, but and really there isn't an easier way to do this. Maybe not. Okay, so the other case would be to find out what the probability of being motivated by money, which is just a single number in the table, which is also 31. So the probability of not, so I'm going to do this, the probability of not, that's what this is. So the probability of motivated by money is going to be the number of people that are motivated by money divided by the total number of people that are to choose from. And therefore, you can calculate 1 minus this number. which one is 100 divided by 100, just to get a common denominator. And so 100 minus 31 is 69 over 100. You see we get the same answer. So in this case, here you have to add two numbers together to get that. Here you don't have to add any numbers, but you do have to find a common denominator. So 6/1 isn't it? Okay, so 10. It's a male and motivated primarily by money. So this is one of those conditional, well, again, there's two ways you can look at it. You can just look in the table and see that the intersection of male and the money is 19. So that would be 19 over 100. Now the question is, how do you do this as conditional probability? So the question of being a male, and then the probability that being a male, that, well, the probability of being a, I guess there are two ways we could do this, so let's do it both ways. Probability of being a male first, and the probability of being interested in money that you are a male, given that you are a male. So that's the conditional probability part. So the first is we start with everybody. So the probability of being a male is 48 divided by 100. Then the probability of being interested in money if you are a male, well, what you would do there is you would take the total number of males, which is 48. That's your denominator. And of the 48, 19 are interested in money. And you can see that the 48s cancel out, and you get 19 over 100. That would be the way going that direction. Then you could do the probability that you pick somebody who's interested primarily in money, and then multiply the probability that if you, probability that you are male, if you are interested in money. And you multiply those together. So the probability of being interested in money is you look at the total. So there are 31. So we're not worried about the male part to start with. We're just interested in if you are interested in money. So that's 31 out of 100. Now, given that you are a male, given that you're interested in money, what's the probability that you're a male? Well, in that case, you take the number of males that like money divided by the total number of people that like money. So this is the number of males that like money divided by the total number of people that like money. So given that you're a male, the probability are we doing this right? No, the probability you like money is 31 out of 100. Then given that you like money, the probability that you are a male, you have to take the number of males who like money to the total number of people who like money. And again, the 31s cancel out, and you end up with 19 over 100. So there are really three ways to do it. In this case, because you have the table and you have the combination, you can look at it directly. Or you can do it in this conditional probability sense. Okay. So number 11 says, male, what is the probability that you're male, given that the primary motivation is a sense of giving to society? So that's male, and, well, actually, this question is given something. So what they're asking for there is the probability that you are a male, given that your primary motivation is giving. Just like over here, what is the probability, given that the probability is, given that the primary motivation is money, what's the probability that you're a male? So it's the same kind of deal. You look at the numerator was the number of people that were males in the column that says sense of giving to society. So that's going to be 14, and you divide by the total number of people, men and women. So you get 14 over 31. So this is this second part, the question they're asking there. Here, you can answer this question just by looking at it, or you can do it in terms of conditional probability. And then number 12 says, motivated primarily by money or creativity, given that the student is female. So in that case, what you have to do is, given the student is female, so that is the primary information. So what you do is the denominator is set by this particular thing. Just like here, 31 people were interested in money, 48 people were males. So the same kind of thing applies here. So given that the student is female, then the denominator has to be 52. And then what you do is you add the two together. The or means you add two of the responses. So money or creativity. So there are 12 out of the women that like money. There are 23 that like creativity. So you add this together and you'll get 35 over 52. And you can't actually reduce those around. So anyway, that's how this works in this case with the table. Okay, what's next? 37 through 40. So this is the probability in warehouse grocery shopping. Therese Feltzer manages a grocery warehouse which encourages volume shopping on the part of its customers. Therese has discovered that on any given weekday, 70% of the customers' sales amount to more than $100. That is, any given sale on such a day has a probability of 0.7 of being more than $100. Actually, the conditional probabilities throughout the day would change slightly depending on regular sales, but this effect will be negligible for the first several sales of the day, so we can treat them as independent. Okay, so what it's saying is the probability of sales being greater than $100 equals 0.7. So that also means the probability of the sales less than or equal to $100 is 1 minus that, which is 0.3. And it says find the probability of each of the events. The first two sales on Wednesday are both for more than $100. So this is kind of like the basketball free throw situation. We have two sales, so it's a multiple part. They are independent of each other. So in this case, rather than the probability of A and B being such that I'll write this down, probability of A times the probability of B given that A happens, because these events are independent, we don't have to do the conditional probability. We just have to multiply the probabilities of each one happening by themselves, and you multiply them together. So 37 says the two sales are both more than $100. So that means that we have the probability of the first sale of being is 0.7 to be greater than $100. So all we have to do is multiply the probability of 0.7 for the first sale and 0.7 for the second sale, just like here. And if we have more steps, we just keep multiplying together. So the probability of having both sales greater than $100 is 0.49. Okay. So that's 37. First 3 sales on Wednesday are all for more than $100. So in this case, you have 3 sales greater than $100. So again, you do the probability of the first sale being greater than $100. You multiply it by the probability of the second event times the probability of the third event. And if you multiply those 3 things together, you get 0.343. So that's the probability. And so, because this is not 100, this is not 1, the probability is less than 1. Every time you do something, the combined probability of all 3 things happening is less. Now, the next one says none of the first 3 sales on the Wednesday is for less than $100. And you may think that that's just 1 minus that number. But this represents all 3. But 2 out of the 3, 1 out of the 3 are all in the not part. So greater than doesn't mean all less than. All greater than means this. So it's in between. So what we have to do here is all less than. That means we have to all less than $100. You look at the probability here. Originally, the probability of being less than $100. Again, this is a random thing where they're independent of each other. So in this case, you multiply 0.3 times 0.3 times 0.3. And when you multiply all this together, you get 0.027. So the other arrangements are 2 out of the 3 sales are greater than 100. 1 out of the 3 sales is greater than 100. And then the other 2 are all the sales are greater than 100, or all of the sales are less than. So the other ones have to add up with these 2 to 1 to cover all bases. But we're going to talk about that when we get to this binomial stuff in section 4. Okay, so 40 says exactly 1 of the 3 sales on Wednesday is for $100. So the way we do that is we look at the 3 cases of exactly 1. So the cases are, I'll do first, second, third. So these are the 3 buys. So we'll say greater than 100. This one's going to be, actually, yeah, greater than, this is going to be less than 100. This will be less than 100. Okay, so that's the first, exactly 1. I could either have the 1 in the first position, I could have it in the second position, or I could put it in the third position. So you can see each one of these are greater than 100, and the other ones are less than 100. So it's exactly 1. There are three cases where that happens. So the probability of this case happening is going to be the case for greater than 100, which is 0.7, times the probability of getting less than 100 for the second case, and less than 100 for the third case. Then the second one is you've got the 2 lower probabilities for the first and the third. And then finally, the last one, you've got the first 2 are the low probability. And the last one is 0.7. So you see we get the same number. It's just a different order. So whatever this number is, I just have to multiply by 3, or I can write it down 3 times. So we get 0.7 times 0.3 times 0.3, and you get 0.063 for each one of these. 0.063, 0.063. So the probability of exactly 1 greater than $100 is just the sum of these three. So you have 0.063, actually just times 3 because there's 3 of them, times 3, and you get 0.189, 0.189. So the answer is that. In section 4, we'll be able to come up with an answer, and the reason you can is because these are the same numbers. It's 0.7 times 0.3 times 0.3 in different orders, and there are 3 of them, and there's a pattern. There's a mathematical way you can predict how many times you multiply this same number by itself. Okay, so that was that one. We'll stop there, and we'll have another one for the next couple of groups.